Good day, everyone. My name is Shih-Hao Chang from Tankang University, which is located at New Taipei City, Taiwan. Today, I want to present our paper called A Visible Light Communication Positioning Mechanism in Industrial Logistics Management, which present in IEEE AINA 2016 in TeNAS workshop. Our agenda today will talk about introduction in visible light communications. Secondly, we will provide motivation and the related work, including the industrial logistic management and the related research works. Third, we're going to present our current challenges in visible light communication. Fourth, we will propose our mechanism designs. 5. We will talk about current evaluation result and give a Q&A in the end. In visible light communication, he have many attractive characteristics, including visible light can provide this is a new wireless communication technology using visible light communications, which is visible light belong to the optical wireless communication, where the visible part of the spectrums. Therefore, his wavelength is between 400 GHz to 800 GHz. Visible light spectrum has immunity to electromagnetic interference and no interference with the RF systems. He have very attractive characteristics, including his functionality. He can illuminate and communication at the same time. Second, he is free to current radio regulation and the spectrums. Third, in the security part, he can provide what you see is what you send. Fourth, in the healthy, he is proved he is harmless to human bodies. Visible light communication, he using a light emitting diode, which called LED. LED is very small in size. Secondly, he have a relatively long life compared to the light bulb. The third, he's more power efficiently and more power using less powers. And he provides relatively fast responding time. And six, he is difficult to damage with external shock. 7. He can have high tolerance in humidities. And 8. He have a minimum heat generate. So you can see in the diagram the LED price is going down, and compared to the previous different light source, and its brightness is going to increase compared to the previous traditional light technologies. And visible light communication using low-cost LED and provide very fast data transmission rate. As you can see in the below diagram, right? It can provide and reach more than 300 megabps per second, and very using simple visible light LED. And LED have become widely adopted as a power saving light devices. It's very low cost and is omnipresent. Visible light communication is a fast growing technology in recent years to provide data communication using low cost and energy efficient LED and photodiode. The visible light source can be modulated at high speed, so there is the potential to transmission data as well as provide illumination. As you can see in the diagram below, the LED can using modulations to have on and off. The bright can be 0, dark can be 1. So he can using OOK on-off keying technology through the visible light, and then transmission signal to the photodiode to receive And once he receives, he can decode, demodulate the data, become an ID or data to receive in the client side, such as PCs or even mobile phones. So visible light communication, you have many potential applications, and currently they already have some application in hand, such as he can using mobile phone side LED to transmission the data to another mobile phones, and he can it can provide content sharing and the data transfer from one mobile phone to another mobile phone. Second, he can using mobile phone to fix located devices such as TV or another any media player who have visible light receiving capabilities. he he can provide such as in the second um, in the second sections you can see the mobile phone can transmission the data or file transfer or video streamings or commerce capability to any media player such as such as TV or karaoke such kind of applications. In the third sections, you can see he can provide infrastructure to mobile. Uh, you can see like you can using the traffic light or using the office light to transmission the data from light source to the receiving mobile phones, or you can using traffic light to send data to the cars, or even in the airplane, you can using airplane light to transmission data and receiving in your PC. So he provide indoor navigations, indoor positioning, and information broadcasting. Compared to with others, visual light compared with the RF, you can see visible light have many dramatic or attractive characteristics. So, such as in bandwidth, visible light communication is very large. He can provide 400 nanometers to 700 nanometers wavelengths. He don't have a EMI interference. He provide line of sight communications. He can provide low power consumptions and visible securities. Also, in the infrastructure, if you already have LED as a illumination devices, LED can be also send data to the end terminal, and he provide also limited mobility and short coverage in distance. The RF have some advantage compared to the LED, such as it can have provide more widely distance, but he also have a drawback in securities. In the motivation part, why we using visible light? Because we understand current industrial logistics management is so complicated. Because industry logistics is in general is the detailed organization and implementation of a complex operation. In a general business sense, logistics is the management of the flow of the things between the point of origin and the point of consumption in order to meet requirements of customer or corporations. The resource management in logistics, including physical items such as food, material, animal equipment, and liquid, as well as abstract items such as time and information. The logistics of physical items usually involve the integration of information flow, material handling, production, packaging, inventory, transportation, warehouse, and open securities. In industrial logistics management, in this area is related have many related applications ranging from forklift tracking for precise and automation tracking of goods and pallets to the pursuit of the mobile operation terminals in manufacturing environments. In logistic industry, damage, a delay, or loss of goods create inefficient and lead to higher costs. Offsetting this issue require amazing all the information need to monitor and control the logistic flow in real time. The gap between the physical and information world can be filled by deploying active intelligent objects and the combine of wireless technologies such as visible light communications. In the background related work, we have referenced 5 different papers, including like indoor visible light communication challenge and perspectives. And we also reference 3 indoor positioning using visible light papers. And the final, we have using the current new standard IEEE 820.115.15.7 visible light communications, modulation schema, and timing support. In the current challenges, we find the visible light have the performance was limited by the noise and interference. The composition of all these current are usually referred to the background current is LB, which can be expected as LB is equal to L nature and plus L artificial. The shot noise is independent of the signal and can be modeled as a wide Gaussian with one side PSD. And you can see in the hotspot coverage, we can using the visible light communication AOA technology, which is using the the angles of the visible light, and also by using the FOV is the highest angle which the receiver can receive signal rate for any optical receivers. The relationship between the divergence angle and the acceptance angle is worst case alignment can be expressed as psi equal to R cosine H dividing by D. The DC channel gain can be written as the below formulas. The above equation can be written as a function of horizon and the vertical distance as the formula present below. And the relation among horizon separation D horizon D and the vertical separation H can be expressed as below. The path that the user travels can be simplified expressed with the formula below, and the instant distance from the center of coverage to the mobile user can be calculated as the formula below. We're using the following toolkit, including PDA E-Link-A and also the USRP N210 and the Wave Expert device, and we're using third LED driver board and laptop. In order to provide better understanding of the characteristics of visible light communication in indoor environment, we perform a field of trial in VLC to observe. We test the receiving signal power at different locations with a range and packet error rate and the signal to noise ratio. Here we also illustrate the evaluation environment as below. In the evaluation environment, the modulation and the packet format, the data is associated using 4 ppm data, and the following binary data are skill code, including the preamble and F-type, and ID and the data, and the 2 bytes of CRC code. The current evaluation result we using packet reception rate and the defined distance. Figure below show the relation between the reception rate and distance. We using PDA-10A as our photodiode receiver, and we also declare the input power to USRP by install an 40 dB attenuator before the signal input to USRP. The diagram presents the packet reception rate at different angles. We find out the theta over 15, the packet reception will drop down quickly. Figure below explore the relationship between the receiving power and distance inside 1.8 meters. For this experience, received power was measured in different conditions. We installed 2 different types of attenuation before the signal input to USRP, 30 dB and 40 dB, and measurement the difference between the received power in same distance. In path loss part, the figure below explores the relationship between the receiving power and the relationship between the receiving power and the distance. The diagram shows the long distance and log receiving power to present the path loss model. The reference distance from 0 to 1.8 meters, and the result show the signal intensity is inversely proportional to distance squared from the light source. The packet reception rate and the VS signal to noise ratio. Figure shows the relationship between the packet reception rate and the signal noise ratio. We utilize PDA-10A as our photodiode receiver, and we also declare the input power to USRP by install the 30 dB attenuation before the signal input to USRP. The diagram presents the higher SNR will have better packet reception rate, where SNR value is equal to 10. The performance PRR is close to 1, which presents the signal will only need to adjust to optimize range, then PRR will have a good performance without waste extra power. In the conclusion, invisible light provide the merits for secure information exchange, harmless to human body, unregulation, eye safe, and is excellent, applicable in some radio frequency restrict areas such as inside an aircraft and hospital. In this study, we want to understand the relationship between the receiving power with distance position model, which is calculate the location information while user is mobile of the visible light part. From our trial experience, we understand the visible light communication has provided characteristic in line-of-sight communication environment due to its path loss model present the signal intensity is perfect inversely propagation to distance square, and the SNR value is equal to 10. The performance PR will close to 100%. Our future work is to complete this model, which can be used as a mathematical tool for evaluation and performance visible light hotspot before it can deploy in reality. Thank you for your listening, and we can have a Q&A time. If you have further question, you can contact Dr. Lin Qi and or Dr. Shih-Hao Chang. Thank you very much indeed. Here's our conclusion and the reference. Thank you. 拜拜。